Okay, let's look at some examples and some notes for section 6.2 of our textbook. So 6.2, the book titles it Solve for Multivariable Linear Equations for a Given Variable. So I know we covered this in in Algebra 1. We call this solving explicitly, and basically all it means is you're solving equations when equations have more than one variable in them, and the skills are still there. You guys have been solving equations for a while now, so all the skills that you've attained for solving equations, they're not going to go away. You're going to utilize those same skills here. Just instead of, when we solve, we get, x equals some number. Now we're probably going to get a bigger mess here. We're going to get x is equal to a lot of different variables. You're going to see this, or you should have seen this now that you guys are seniors. I know a lot of science classes use this. Maybe a chemistry class, or probably a chemistry class where you have a lot of formulas, kind of manipulating them and solving for a formula, a specific variable in a formula. All right, so let's get into this. All right, we'll just get into a variety of examples here. So I have the equation 3x plus 2y is equal to 7z, and we are asked to solve for x. So just remember, when we are asked to solve, it's basically implying that, we need to manipulate this equation until the x variable is completely on a side by itself. Now, when we're dealing with variables, we're dealing with a lot of different variables. Being able to understand what a like term is really comes into play here. Remember, a like term, same variable, same exponent. All right, so we need this guy isolated, right? So he's on the left side of the equal sign. I typically try to think, if I need that variable on a side by itself, I'm going to leave it over on that side, and I'm just going to move everything away from it. Here we go. So I don't want any of this 2y, right? So this is being added to a 2y, so I'm going to subtract 2y. All right, and we did nothing to the 3x. 2y minus 2y went away, equals, and this is what I'm talking about, where, really pay attention to your like terms. 7z minus 2y, right? These aren't like terms. These cannot be combined, right? We can't collect these things. So 7z minus 2y is just, 7z minus 2y. All right, and now this is stuck by multiplication, right? We know the skill to undo multiplication, we divide, so I'm going to divide both sides through by 3. And 3 over 3 is just an x. And then now we've got this big mess over here. It depends, on a multiple choice test. Sometimes you might see it completely a little bit more broken down, but this is it. There's nothing more we can do to this guy here. Okay, maybe they might try to simplify it a little bit more. You may see it like this. So instead of dividing the whole thing is now divided by 3. Each little piece in there has its own divisor there. They both mean the same thing. The only thing is, you may see it more like this. Say if this was like, I don't know. Say if this was a 6, 3 goes into a 6, so you might have seen just a 2y here and not the 3 anymore. Just different things to kind of look out for when we're simplifying here. But I don't know, sometimes more variables I think makes things easier, because sometimes there's not more to kind of clean up there. Sometimes it looks a little bit weird and kind of odd that this is the entire answer, but there's nothing we can do. There's nothing more we can simplify. All right, let's look at this one. Zoom in a little bit. All right, we have v is equal to 4/3 pi u squared w. We need w, right? So really pay attention to what variable it actually wants you to solve for. In this particular case, we need w. So we need this guy right here to be isolated. A lot of different routes you could probably take with this. The route I'm probably going to start with is this 4/3. I don't want that over there. So I am going to move it. Now, this is 4/3 times pi times u squared times w. So this is all stuck by multiplication. So what I'm going to do is I'm going to divide this off. And remember, the way we divide fractions is multiplying by the reciprocal. So what I'm going to do is I'm going to multiply both sides by 3/4. Let's see if I have a different red marker there. This one isn't showing up. I don't. All right, so we're going to multiply by the reciprocal, right? When we divide fractions, same thing, multiply reciprocal. So here we go. So by multiplying, a fraction by its reciprocal, it's going to take it to 1, right? That's what we want. It goes away. So on the left side, now we could say 3/4 v, or I'm going to say 3v over 4. It doesn't matter. I understand that it's v over 1. So I'm just going to keep the fraction and keep the 4 in the denominator. So on the right side, now we have pi u squared w. And again, we are trying to isolate w. So all of this is stuck by multiplication, right? So since all of this is stuck by multiplication, I can go ahead and divide all of it off, right? So everything but the w, we want the w to stay, so I'm going to say pi u squared. And we're going to divide that by the other side. So when I divide the left side by pi u squared, we've got 3v, but now the pi u squared goes in the bottom with the 4. And again, when we divide that off, we're just left with the w, which is exactly what we wanted there. And I can put it. All right, so again, I know a lot of these variables can kind of look intimidating, but really it's just kind of a formality of following the steps, and then, there's really not much more you really need to collect. All right, a couple more examples. C is equal to 5/9 times f minus 32. So we can see that we have distributor property here, but we need this f by itself. So if I distribute this 5/9 to the f is getting a little bit more complicated instead of simplifying. We want f to a side by itself. Focus. There we go. So maybe a trick you remember from Algebra 1, and we don't have to distribute here. This is still stuck by multiplication. So again, we can divide fractions or multiply by the reciprocal. So I'm going to go ahead and multiply both sides by 9/5. I have 9c over 5, or 9/5 c, is now equal to f minus 32. Now, you could have distributed there, but I think you're going to add a couple steps. If I don't need anything of that 5/9 and that's just causing more problem to me, I'm just going to move the whole thing away in the beginning. And then now, the last step is, this is being subtracted by 32, so I'm going to add 32 to both sides. All right, and the first part that we found, we had 9c over 5, and now we're adding 32 to it. All right, and again, nothing here can be simplified. This is as far as we need to go. The f is completely on a side by itself, so we're done. Next one here. You might have seen this one a lot in Algebra 1 as well. This is the standard form of a line, ax plus by equals c. And you're asked to solve for y. So I know I did this a lot with my Algebra 1 students, solving for y, because, well, linear equations is y equals mx plus b. So we needed to get stuff in a linear form to be able to find the y-intercept, be able to identify slope. So you may come across something like this, and they ask you, what's the slope of the equation? Well, the only way we know that is for y to be on a side by itself. So we need to solve for y. All right, so I need this guy on a side by itself. Again, I'm going to leave him alone. I'm going to move everything away from it. This 2x, I don't want anything to do with that 2x. I want the entire thing moved over the equation. All right, so that's going to go away. Now I want the negative 4y is equal to, again, understanding like terms, that's a constant, this has a variable. They don't go together. And it doesn't matter which one I write first. I can say 20 minus 2x, or I could say minus 2x plus 20. Just make sure the signs to the left of them stay. This is a positive 20, that's a negative 2x. I still have a positive 20, I still have a negative 2x. All right, we have one step left. This is stuck by multiplication. I'm going to undo multiplication through division. And, you know, the first question, I went ahead and divide everything through by 3. Or you can understand when we multiply or divide, everything has to get multiplied or divided through by. So I'm going to go ahead and divide everything through by this negative 4. All right, let's look to simplify. Negative 4 over negative 4 is a positive 1, which is exactly what we wanted, right? We have a positive 1y. We have negative 2 over negative 4. Well, negative 2 divided by negative 4 simplifies to be a positive 1/2. And then lastly, I've got 2 over negative 4, 20 divided by negative 4, and 20 divided by negative 4 is a negative 5. All right, not too bad there, hopefully. 2 more examples, just some different things you may come across. All right, so very similar to what we just saw, but now you've got all variables. Let's see how we take care of this one. Again, we need to isolate y. Same steps, we're going to subtract the ax away. That's going to go away. I'm left with now by is equal to, again, these are not like terms, so we just need to rewrite them. And then lastly, this b is stuck to the y by multiplication, so I'm going to divide it. And again, we can divide the whole thing, or you can divide each individual term or each individual piece that you see. Then we look to simplify. Well, the b's are going to cancel, right? They're going to go to 1. So we have y is now equal to negative ax over b plus c over b. So if you notice, the last example that we did was set up exactly like this. We took the same exact steps, but this is why I kind of mentioned before, sometimes it's easier to handle just all variables because, well, we didn't have to do anything. They all got left alone. Here you had to do a little bit more thinking in the sense that, you know, we had to simplify 2/4 as a fraction, and you had to simplify 20 over 4 to save 5. In this particular case, right, we didn't even have to simplify. There's nothing in common that we could have reduced here. So even though, like I said, might look more intimidating, might look like a bit of more of a mess, sometimes it takes less steps to do it. One last example here. PV is equal to nRT. Again, we need to pay attention to what we need to solve for. This particular case, we need to isolate R. All right, so again, I'm not going to touch that R. I'm going to move everything away from it. So notice what's next to it is I've got an N and I've got a T. Well, understand that these things are stuck to that R by multiplication. Well, if I need to undo multiplication, we do that through division. So we don't have to take 2 separate steps here. I don't want the N nor the T. So I'm going to, well, divide both sides by N times T. And it doesn't matter that they're not next to each other. Multiplication is cumulative, so we can move it, right? 3 times 4 is the same thing as saying 4 times 3. So this nRT is the same thing as saying I could have said RNT, right? So multiplication doesn't matter what the position is. So now I'm dividing by NT, right, which is exactly what I want. On the right side, I'm left with that R that I want. And on the left side, I've got PV, and I'm dividing by the NT that we divided through by. Again, now that you're just dealing with variables, none of these variables are the same, so there's nothing to really collect and combine. You're done. So these were 6 examples of being able to solve explicitly or solving when we see a lot of different variables. Again, very similar to how you solve equations. I know you've been solving equations since the 7th grade. Maintain those skills, but now just look for your like terms and see what you can collect or not.